Welcome to this tutorial by DG Technologies. In this episode we will present a LIN demonstration using the Gryphon S4 and the Hercules software. Let's first take a look at the view of what we will build by the end of this demonstration. Here you see Hercules is displaying the LIN data in the scrolling window in the upper left, the decoded engineering units data in the signal window in the lower left, and the plot of the data. Using an LDF file, Hercules has set up the Gryphon as an LIN master and is running the schedule defined in the LDF file. Let's take a look at the actual hardware that we will use for this demo. The LIN device is a turn-signal stalk. It has right and left turn switches. It also has intermittent wiper controls for the front and back wipers, washer controls, and headlight high beam controls. As we change these controls, the LIN device outputs new data on its next response to the LIN master. The Gryphon S4 protocol adapter connects to the LIN device through an optional plug-in LIN card. The Hercules software that runs on the PC communicates to the Gryphon over Ethernet. Now let's take a look at some actual data from the LIN device. First, we will use GryphRx to view some scrolling data. If you are not already familiar with the Gryphon tools, GryphRx and GryphTX, that are run on the Gryphon over a telnet connection, you can watch the other tutorial videos on basic Gryphon tools. We run GryphRx on our LIN channel, which in our case, on our Gryphon, is channel 5. Now that GryphRx is monitoring the received data on the channel, we will run GryphTX to transmit some data to the channel. To simulate the LIN master, we will transmit LIN ID hex 22, which is the ID of our LIN stalk. We send the message once, and GryphRx reports the wake-up event on the channel and shows us the ID and the data response from the LIN slave. We see TX for transmit, the Gryphon timestamp, the LIN ID header, and the 4-byte data from the LIN slave. The remote tag indicates that this data comes from a LIN node other than the Gryphon. GryphRx then reports the channel sleep. Now let's start a periodic transmit, and we will be able to observe the LIN slave data change over time. We'll send our 22 ID every 250 milliseconds and iterate 1,000 times. We see the result of the LIN master putting out a periodic request on the bus and our LIN stalk responding with its 4 bytes of data. Now let's change the data. As we change the position of the controls on the stalk, the response from this LIN slave changes accordingly. When I change the wiper position, you can observe that the third data byte changes from a 0E to a 0D. As I change it further, the data changes to 0.5, then 0.4, 0.3, 0.2, 0.1, and finally 0.0. As I change other controls on the stalk, other bits in other bytes change as well. Using GryphRx and GryphTX, we have quickly verified that our LIN bus is up and running and our LIN slave responds to master requests. Now let's configure the Hercules software to read in an LDF file and display the decoded information from the definitions in the LDF file. In Hercules, we connect to the Gryphon hardware by specifying the Gryphon IP address. We select the LIN channel, channel 5 in our case, and click Advanced Configuration. In the Advanced Configuration window, when we select the emulation option, we're able to then load in an LDF file. Once loaded, click the Configuration button and you can select which node or nodes in the LDF file you want the Gryphon to emulate. This is one of the most powerful features of the Gryphon. You can use the LDF file that you would use in vehicle testing, and the Gryphon can emulate all of the other nodes that are on the vehicle bus. You don't have to have a separate LDF file to test on the bench. Since this is just like in-vehicle testing, you can replace the expense and time-consuming of in-vehicle testing with bench testing. Next, we bring up our display windows. One window is the scrolling display window, just like the scrolling display of GryphRx. Our other windows are the signal monitor window, which will show the decoded information, and the final window is the plot window. In Hercules, we also need to associate a database. The database is created in Hercules from the information in the LDF file. Detailed instructions for creating and saving the database are in the Hercules documentation and in the LIN class lab instructions. Now we can right-click in the Signal Monitor window and add some signals. We select all of the signals that are defined and select them to view in the Signal Monitor. We can select some signals to view in the plot window by clicking the Select button. We're ready to start. We click the Start button. This will start the master schedule that we selected from the LDF file. You see the scrolling data in the upper left, the signals in the lower left, and the plot on the right. Just like we did before, we changed the controls on the stalk. As we change the intermittent wiper position switch, for example, you'll see the signal change in the Signal Monitor and also see the plot line on the plot change. As we change the other controls on the stalk, the changes are shown in the plot and on the Signal Monitor. And so we've achieved our goal of using Hercules with the Gryphon to emulate a LIN bus using an in-vehicle LDF file. To review, we've started by verifying our connections and our slave using GryphRx and GryphTX. We then configured Hercules and ran the emulation. You can save your configuration in Hercules so that you can use the same configuration next time.